Last couple bit of questions, then you should be good to go. Turn in your notes early. Why not? Let's just get it done. But let's go ahead. We're going to look at this problem, inelastic collision. Then the last problem is elastic collision. Here, before we take our quiz, before we look at this, I want you to recall, number one, momentum is going to be a vector quantity. The answer is yes. If you get a negative answer because of it, that's A-okay. I am not going to take these vectors into account at this moment because a lot of my students don't plan to go into engineering, and so getting into a more difficult engineering vectors becomes a little bit difficult. So let's just focus on the numbers. All right, now with that said, it says that I have car number 1, here it is, and they gave me the mass, M1. Wait a minute, we're about to take a quiz, and I printed it out, and there was a question that I recall that is in pounds. We do not use pounds. You have to go from pounds into kilograms. How do we do that? Do we recall? We did that last semester. One more time. You're about to have a quiz, and there's a number in pounds. Pounds are not acceptable. You have to convert it to kilograms. How do I get it? I get the pounds and I divide by 2.2. One more time. You get the pounds number, divide by 2.2, and that is converting it into kilograms. Don't forget, because you're going to have a quiz in just a moment. But this is in kilograms, so that's good. It tells me that it's traveling V1B because there's no collision yet. I understand there was a direction. I just want to exclude directions. My car number 2, M2, also has a mass in kilograms, and it is traveling V2B 6 meters per second. Car 1 crashes into car 2, and they stick together, which makes it an elastic collision. It says here, what is the speed, velocity after the collision? Okay? After the collision, what is that velocity? So here's what I see. I visually see car 1 plus car 2 gets into this crash, and they become a new big car 1 plus 2. And that means that the conservation of mass needs to be taken into account. My equation that is on the formula chart that you are going to be given looks like this. And when we look at that formula chart, it's going to tell me that my M1, M2 equation, which is there, here it is, which is right here. Here's my momentum, here's my impulse, and if you look at it this way, impulse equals momentum, so 1, 2, 3, and the law of conservation of momentum is this generic equation. Well, I need to modify it if it's going to be an inelastic or an explosion. Okay, now this is an inelastic, and so for this situation, M1V1B plus M2V2B equals M1V1A plus M2V2A. Now, over here with my drawing, on the right side, I only have one object. So I need to cancel something out. But I cannot cancel out the mass. I'm going to conserve it, and I'm going to say plus M2. Now, hopefully you tried. If you didn't practice this question on your own, that's okay. Do it right now together. Let's go ahead and plug in our numbers. 300 multiplied by 10 equals, plus, forgive me on that. 200 multiplied by 6 now equals, the equals is my collision. And remember, M1 is going to be added to M2. 300 plus 200 multiplied by the velocity after the collision is my unknown variable. Okay? The velocity after the collision. All right, let's go ahead and do this math so that way we can kind of simplify it and answer this. 300 times 10 is going to be 3,000 plus 200 times 6 is going to be 12 plus 2 zeros, so 1200 equals 300 plus 200 is 500 multiplied by VA, the velocity of this collision after. All righty. Again, let's keep going. I'm going to just do this step by step. 3,000 plus 1,200 is going to be 4,200 equals 500 VA. All righty. Well, I will say that I need to isolate the velocity, so I'm going to divide by 500, divide by 500. The velocity of car 1 and 2 that crash together comes out to 8.4 meters per second. Not too bad. Hopefully that's what you got with your calculator as well. Again, just trying to get a little bit of practice before we take our quiz. Okay? We will go over this, or I will actually post the grades and the answers on D2L over the weekend, so that way you can see, like, oh, here's my grade, and this was the answer key. And then next week on Tuesday, you can swing by and pick up your quiz, so that way you can personally see what you missed and what you didn't. But again, I will post the quiz up on D2L over the weekend for you all to print out and practice. The next question down here that we have not done for this class is an elastic collision. Elastic collisions means that they bounce, hit each other, and they don't stick to each other. Not a problem. It looks like two objects over here. There's a before and there's an after. Now, remember, if they don't give us the after mass, it's okay because mass is always the same, right? Just because you bounce a ball up against the wall, it didn't lose mass when it came off of the wall, okay? So, but they did give us the mass, the before and the after, which is good. I went ahead and wrote out the equation for you, and I asked you, hey, what type of collision this is? And I wrote it actually out over here. Hey, it's an elastic collision. So there goes the answer. On elastic collisions, looking at the formula chart over here, it is going to maintain this equation. But wait a minute. What if somebody asked this last class period? And so I thought this was a really good question. Because on the test next week, you're going to have a question like this. They said, Miss Munson, what would it look like again if it was like 3 objects that were going to collide? And just in case, it would be M1V1 plus M2V2 plus M3V3 equals M1V1 plus M2V2 plus M3V3. Okay, because on the test, I'm guaranteeing you, whether it's an inelastic, elastic, you need to, or explosion, you need to know that however many objects you have, you need to have it on both sides. The momentum of all the objects on both sides. So just tossing that out there, you know, as a reminder. Now I'm going to move this out the way. I gave you the formula over here. I'm going to go ahead and fill it in. That's going to be the 4, which is the mass of object 1, multiplied by 10. Oops, 10. I'm going to add that to the mass of object 3, multiply it by 12, equals, I'm going to get the mass of object 1, which is the same, times the velocity. I'm going to add that to the mass of object 2, and my velocity of object 2 after the collision is my unknown, okay? This is what an elastic collision looks like, which is on the formula chart. Let's go ahead and just kind of do a little simplifying. 40, multiply that by, plus that by 36 equals 8 plus 3V2A. Hopefully that's what you got. In physics, please excuse my dear Aunt Sally is super important. So let's follow those orders of operations. I'm going to get 76 equals 8 plus 3v2a. Again, just step by step because I don't want to mess something up. If this is a positive 8, the opposite of that is a negative or subtract 8 on both sides. And when I do that, I get 68 equals 3v2a. So we're coming through the end of this. We're now down to the last step here. I need to figure out what the velocity of object number 2 is. I'm going to go ahead and divide this side by 3 because they're being multiplied. Divide this side by 3. The velocity of object 2 after the collision is ending up at 22.6 meters per second. Like we've really went through this. Our notes are pretty much done. Fill in the last part of it, and please don't wait till next week. Get your notes turned into D2L early. I think that would be the best thing for you. Now I'm moving the notes out of the way. When I do that, I'm going to go ahead and get my homework out. So my homework for this class looks like this. Okay. We have homework number 5 and homework number 6. I would really like to do a problem on homework number 5 and a problem on homework number 6. Which ones? Well, you all are the students. I would much rather ask you all first to see if there's a question that you felt was kind of unsure. So is there anything that you want to pick? Robert, is there by any chance? Which one? Okay, I'm going to do homework number 6 too. Anything on this side, or you feel like comfortable? I definitely am going to do one on 6. And I bet on number 6, it's probably question 12. Yeah, I knew it, but okay. And I am definitely going to do 12 for sure. How about here? Number 5? Okay. Let's take a glance at number 5. That's a good one. I'm pretty darn sure you're going to see a question like that on the test. This bullet one on the test. So let's look at that. Just to make sure that we're all comfortable, then I'm going to turn the page and I'm going to go to number 6. Homework number 6, question number 12. Okay, and if there's anything else, then you let me know before we take this quiz. Alrighty, I have a bullet. Now, a bullet is an object, and they gave us the mass, so I'm going to go ahead and call this right here M1. It enters a watermelon, and the watermelon has a mass, M2. And embeds itself into the watermelon. Embeds itself means that it's going to be an inelastic collision, meaning that it's going to have object number 1 plus object number 2 equals 1, 2 combined. Hopefully that's what you're looking at this moment. The melon is immediately set into motion. Oh. When the bullet hits it, because it got hit by the bullet. So if the melon is object 2, then the velocity of object 2 after it got hit by the bullet is 4. Making sure you got that. The bullet remains lodged inside of the melon. Oh, it's an inelastic collision. What is the entry speed of the bullet? Question mark. What is the velocity of that entry speed? Wait a minute. Is that a B or an A? Is that a velocity object 1? Because the bullet is object 1. Is that a B or an A I'm looking for? Is it a B or an A? Is it an A? Is it a B? Is it A, B? B, A? It's a B. Shelby was right. She was right. It was a B. It was before. And the reason why is because this is the velocity. And Miss Munson, you wrote 2. But it's actually 1 plus 2 because it embedded itself. This watermelon is not only object number 2, but it's also object number 1 because it got embedded. I'm missing a number. What am I missing? I got mass, check. Mass, check. Mass of 1 and 2, check. I have the velocity after because remember, the watermelon has the bullet inside of it. So they're inelastic. So I do have the velocity, check. Here, I have that velocity. I'm looking for object 1's question mark velocity. What is the velocity of the watermelon before it got hit by the bullet? 0. Because immediately it started to set into motion, meaning before it got hit, there was no motion. So the initial velocity of that watermelon was 0. Good call. So the watermelon immediately was set into motion. So the velocity of object 2 before the collision is 0. Check. I have that number. So I don't know exactly, again, I understand if you're going to chat GPT this or whatever, perfectly fine, but I want to make sure that we understand it. So that was a great question. Let me go ahead and let me write out my equation. M1V1B plus M2V2B equals M1V1A plus M2V2A. And remember my picture over here? I've got to cancel something out, but I have to conserve the mass and say plus M2. Okay? Let's go ahead and do that. Now, I'm going to go ahead and plug in my numbers. The mass right here of the bullet, 0.025 times the velocity, which Shelby was correct, I was just messing with her, is V1B unknown, plus, here's the watermelon, 2.35 times the velocity, Ruby did really good, that was 0, equals 0.025 plus 2.35 times the velocity of 4 after they were combined. Hopefully that makes sense. If this is what you found or whether you solved it yourself, hopefully it's all right now correct. Now the great thing is I love zeros because I can just cancel that part out. Now for this situation, it's going to be 0.025 multiplied by V1B equals, I need to add those two numbers together. Unfortunately, I'm just doing it right here on the spot, so let me just double check. 2.35 plus 0.025. Oops. Miss Munson, don't show that to Mr. Beast, please. Okay, 2.375. I'm going to multiply that by 4. That comes out to 9.5. Hopefully that's what you got. Now I got to isolate, divide this side by 0.025, cancel, divide by 0.025. So let's do that, divide by 0.025. The velocity of the bullet before it hit the watermelon was 380 meters per second. Hopefully that's what you got. If you did it and you AI'd it, well, great. But I hope you understood it, okay? Turn the page when you're ready to question number 12. That one also kind of comes out to a tricky one for some students. I'm going to come over here. The answer that I'm going to get may be a little different than what you're going to get. And the reason for that is because if you AI'd it or chat GPT it, then they probably are going to take vectors into account. Again, Vectors are super important. I agree for those that are going to go into the engineering field, but not all of us are going to engineering, okay? And so because of that, I'm not going to sit there and overstress you when it comes to that. Right now, I said, hey, forget vectors. So my answer right now might be a little differently than what your ChatGPT blah, blah, blah came up with. But here we go. Object number 1, its mass is 400 kilograms. It's starting from rest, means that the velocity of object 1 before a collision is 0. And on the previous page, we just saw zeros are okay. It explodes into 3 pieces, meaning that I have one object, it has an explosion, and it should look like this. This is what my equation is going to look like. Okay. Piece number 1, my mass of object 1 after the collision. Okay, yes, direction is there, but it has this velocity. So the velocity of 1 after the collision. Object number 2, or M2 after, has a mass. Its velocity is going to be V2A, 200. What is the velocity of the third piece? Question mark V3A. Whoa, where's the mass of M3A? Well, hint, hint, you're going to have a quiz in a moment, and this is what you're going to have. It's going to tell you that you have a plate, okay? You have this plate, and you're washing dishes. So this plate has a mass. When you drop the plate, it breaks into 4 pieces. On the quiz, they're going to give you the mass of 3 pieces. You need the mass of the other piece. If you know the mass of the whole, all you have to do is subtract it. So hopefully for homework, that's what you did. So if I have the original 400 and mass of here and the mass over here, the mass of 100 plus the mass of 150 equals 250, then hopefully you came over here and subtracted 250. There you go. And what did you get? 150? There we go. So that is going to be my mass of this one right here. It wasn't given to you. So this is a super good question to look at prior to the quiz. I'm going to come over here and I'm going to say M3A. Just so that way. Okay. Now, my equation, and I'm going to write the full thing. Some of you already understand it and do not need it, but I am going to write it out. M1V1B plus M2V2B plus M3V3B equals M1V1A plus M2V2A plus M3V3A. Now, my equation needs to look like this, so I'm going to Power Ranger morph it, and I'm going to scratch those 2 out, but I'm going to conserve those masses, and I'm going to put them over here. And I'm going to say plus M2 plus M3, right? So hopefully this looks a little familiar now. Alrighty, all of the masses prior, it tells me right here is 400, but the velocity was 0 equals the mass of object 1, 150, multiply that by its velocity of 150. Tell me if I make a mistake with my numbers. The mass of object 2 is 100, multiplied by its velocity of 200. And the mass of object 3, which we solved over here, of 150, I need to figure out the velocity of it afterwards. Hopefully this is where you're at, okay? I love zeros. When I get zeros, 0 times 0 is 0. So for this situation right here, I'm going to 0 equals, well, okay, 150 times 150 equals, it's a big number, hopefully. Double check my answer from this morning. I got 22,500. I could have been wrong. 100 times 200 equals 20. 1, 2, 3, 4. 4 zeros. Oh, wait a minute. 1, 2, 3, 4. 20,000. There we go. Plus 150 multiplied by the velocity of object 3 after. Hopefully that's what you've got. I'm going to go ahead and do just a little simplification and add those two numbers together. 0 equals 42,500 plus 150 times V3A. Now, yes, for those going into engineering, vectors do take into account. I am not going to take vectors into account. So what do I have over here? 4,200. I need to get rid of it. It's a positive 4,200. Let's subtract it. Negative 42,500. Cancel. Negative 42,500. Keep messing that up. Now, for this situation, I have negative 42,500 equals 150 V3A. I understand if you had chat this or something and your numbers are a little different. We are going to go with Ms. Munson and we are going to ignore those vector directions because not everybody's going into engineering. Now I need to isolate this. Divide it by 150. Divide by 150. Cancel. Divide by 150. The velocity of bomb piece number 3 after the collision came out to, I don't know, what is it? Let's see. 42,500 divided by 150, 283.33 meters per second. There you go. There you go. Hopefully that makes sense.